We have the derivative of the natural log of x is 1 over x. Bless you. The derivative of the natural log of u. So if we're taking the derivative with respect to x, and that is a different letter, bless you, we have to tag it, okay? You're going to start seeing u's pop up a little bit. So we're going to have a u, so an x, a y, and a u. Those are usually the letters that are variables. A, B, and C, those are letters that are actual just constants. Okay, so if we take the natural log of u, we take the derivative, which is the same as natural log of x, 1 over u, and then because that's not an x, those letters don't match, then we have to tag it with whatever letter we're using. We've done that with y, now we're going to do that with u. Okay? And then we have the derivative of log of x. Remember this, if it's not there, there's nothing there, that a is considered a 10. Okay, base 10, that's what your calculator's in. If you just hit log of whatever, it's going to be in base 10, or you can change the base. Okay, but log base 10 of x, if there's nothing there, you take 1 over x, whatever this is right here. If it's x plus 3, it's x plus 3, that whole argument right there, and then you multiply it by the natural log of a. If you memorize these, they are very, very easy. If you don't have them memorized, it's not something that will probably just come to you, but it's very, very easy if you memorize it. And again, a lot of times this part's not the issue, it's the cleaning it up that's the issue. You get lost in your cleaning up of the problem trying to get it completely simplified. All right, so the natural log of something. This is our something right here, is 1 over that something. So the natural log of something, 1 over that something, times the derivative of that something. So now it's the chain rule also. So the derivative of the inside, the derivative of the outside, natural log of this something was 1 over x to the third plus 1, times the derivative of the inside, 3x squared. So we would just write that, 3x squared over x cubed plus 1. There is your answer. Okay, that's all you do. Yep. Times by the derivative. No, this one is just that. Are you saying all 3 of these? Nope. This one, which one is it? Which of those does that represent? Just the left one. So they're just up there. Those are the derivatives of log. You have to know each one of them. It's like the derivative of sine is one thing. The derivative of cosine is one thing. So the derivative of the natural log of x is something. The first two are kind of the same. It's just if the x's don't match, if you're not taking with respect to that letter, you have to tag it. But then log base x is 1 over x times the natural log. So if we don't have a natural log and it's a log, then we have to do the third one. Yeah. Always change. Is that your question? Chain rule? Yes. Okay, sorry, I did not understand the question. Yes, you have to use the chain rule always. If there's something in the inside. Like if it's just an x, so here, we really could use the chain rule, but the derivative of x is just 1. That is your question. Okay, yes, you always have to use the chain rule if there's something inside there. Okay. All right, log base 10 of something. Okay, so log base 10 of something is that something, and then those a's match up right there. And then because that something has a derivative, everything has a derivative, we are going to chain that. Remember, when you're chaining things, I've said this every time we take the derivative, you can't take part of the derivative. You're going to clean something up. Like this doesn't have any cleaning up to do, but if you're going to clean something up, you can't say y prime and take the derivative of part and then wait and then all of a sudden pick up and take the derivative of something else. Once you start the derivative process, it is the derivative of everything. It must all be the derivative. All right, so we have 1 over x okay, which in this case is the 2 plus sine x. So 2 plus sine x in parentheses. Most of you are really good about putting your parentheses. Some of you not so much. Some of you don't put it, but you know it should be there. Some of you who don't put it, then the problem changes because you didn't put it, so now you think it's just distributing the term that's next to the thing that's being multiplied. All right, natural log of A. A is 10. And because this is not just x, we have to chain it. If that was just log base 10 of x, we'd be done, but we're not. So then we have to take the derivative of the inside. So the derivative of the inside, there's a plus right there. Now, if you know the derivative of 2 is 0 and you don't have to write 0 plus, that's fine. I'm going to do that though. So the derivative of 2 is 0, because some of you are just rewriting constants down. Okay, don't rewrite a constant down. If you need to put that 0 in its place, put it there. If you don't, that's okay also. But there's some of you not remembering that the derivative of a constant is 0, and you're just rewriting the constant and just bringing it down. Plus the derivative of sine, which is cosine. And then really we could even chain again. The derivative of x is 1, so really we're multiplying by 1 right there, which again we don't have to. You do not have to show this 0. You do not have to show this 1 right there. All right, so y prime equals cosine x over 2 plus sine x times the natural log of 10. You want the natural log of 10 in the front? That's fine. You want to distribute it? That's fine. There's no need to distribute that, but you can if you want. So that is your answer. All you can do. All right, so this is one you can do a couple different ways. You can, I talked about our log rules a second ago. We can use just this right here. The natural log of x equals 1 over all of this times the derivative of the inside, and the inside is the quotient rule. So then we have times the quotient rule, or we can use our log laws. Okay? Both of them are somewhat long. If you do the quotient rule, that gets a little crazy, and the simplifying gets kind of nuts. I can't do it. Which way y'all want me to do it? Log laws, good choice. All right, so remembering our log laws, which natural log base e is just natural log. So natural log laws, they're all the same. All right, so y equals, we're not taking the derivative yet. We're just rewriting this, expanding it using log laws, which is the natural log of x plus 1. Very important that we put that in parentheses, because if not, that means the one's on the outside and not the inside, minus the natural log. I'm going to go ahead and change that to, instead of the square root, x minus 2 to the 1/2. Again, not necessary. Some of you are really good. When I look at your papers, you know that the square root's to the 1/2, and you can do all that without rewriting it, and that's fine. But if it's helpful to write it, a lot of you are still writing it, and that is okay too, because then it just makes more sense what you're doing, and you don't get as lost in your work. All right, so the natural log of something, so now we are ready to take the derivative, is 1 over that something times, using the chain rule, the derivative of the inside, which is just 1. You need to write that, write it. If you don't, that's okay too. But if that was the natural log of something other than x plus 1, we would have to multiply like this next one we're going to have to do. All right, then we have minus. All of this is going to be in parentheses. Again, most of you are pretty good about this negative stuff. If this is all one term, then it all just becomes negative. But if there's two terms, that negative has to go to both terms. All right, so the natural log of something is 1 over x minus 2. And to the 1/2 or the square root of x minus 2, whichever one makes more sense to you. And even if you mix it up in the problem, sometimes write the square root, sometimes write the 1/2. That doesn't matter, because at the end, you just have to know that they're the same when we start evaluating or cleaning it up. Times the derivative of this right here. Okay? So natural log of something is 1 over that something times whatever the derivative of that is. So that's 1/2 x minus 2 minus 1, which would be negative 1/2, times the derivative of the inside, which is just 1. So again, you don't have to write that one. This, oh, you could do that. This 1/2 right here, 1/2 natural log of x minus 2. Yeah, you could do that. It would work. Wait, would it work? I don't know if that would work. I gotta work it out too. Well, but does it make it right? Because we're changing the problem. Oh, the one. Then do we still have this x minus 2? Okay, yeah, it'll work. That'll work. But I didn't do it, so I'm not going to go back now. Okay, we're right here. All right, so now I have 1 over x plus 1. This would never be an answer choice. Okay, never be an answer choice on your multiple choice. You would have to clean that up. All right, so what you have right here is minus, and then in our top, we have a 1, a 1, and a 1, right? We have a 2. We have an x minus 2 to the 1/2. If I bring this down, we have another x minus 2 to the 1/2. And that's what we got right now. Okay? So, 1 over x plus 1 minus 1 over 2. Now think about it. So the 1/2 is the same as the square root, right? And so that's when square root might be a little bit more useful for you, because if we have the square root of something times the square root of something, that gives us that something. This right here is the same as the square root of x minus 2 times the square root of x minus 2. Square root times itself is itself. Okay? And now we're back to an algebra 2 problem. Get a common denominator, right? So this side needs a 2 times x minus 2. 2 times x minus 2. This side needs an x plus 1. Good. You do, because it's not going to be an answer. Okay? Never going to be an answer. Not a choice. You have to learn how to combine things, because this will never be an answer on it. You always have to combine them. So we have 2x minus 4, right? So that's 2x minus 4 times 1, minus x minus 1. That right there, very important. 1 times x plus 1 is x plus 1. Distribute the negative to both of them. All over 2 times x minus 2 times x plus 1. Which then simplifies to x minus 5 over 2 times x minus 2 times x plus 1. You will always have to get a common denominator when you have two terms. Okay? Always, always have to clean it up. So regardless of which way you do that one, it's a little bit easier. This was the easier path using the log laws. Sometimes you can use them, sometimes you can't. But if you can, it's usually a little bit easier path if you can split it up and get rid of the quotient. We don't have to do the quotient rule. That's usually the ugliest, and it makes it a little bit easier. All right, and the last one, so we're back to equation of the tangent line to the curve at the given point. Equation of the tangent line is find the derivative. So we have to find the derivative, but we have a specific point. Y minus 0 equals, we need to find the slope of the tangent line. Since we have a point, we can find the actual slope of the tangent line times x minus e. And y minus 0 is just y, so y times something times x minus e. And on the AP test, I mean, it could be in slope-intercept form. It could be in point-slope form. If it's in slope-intercept, you just distribute and bring that number over whatever form that it's in. I would say leave it in point-slope form. You don't have to change it to slope-intercept, but it has to be one form or the other. Okay? So if it helps to put parentheses, so the natural log of x, this is like that. That's what that means. If you need to put those parentheses there, if that's helpful. Okay, so the derivative of that, the derivative of the natural log of something is 1 over that something times the derivative of the inside. So now we're done. We're done with that natural log, so we can check that off. We're done with it. So now we keep working on the inside. So the derivative of the natural log of x, if that's gone, because we've already done that, natural log of x is 1 over x. So that natural log is done. And then there's an x right there, so we don't have to show, but it's times 1. If that was a 2x, then it would be times 2. If it was an x squared, then it would be times 2x. Okay, so then we took the derivative of all three of those, the outside, and we worked our way in. So we want to know the derivative at e. So we plug that in, 1 over the natural log of e times 1 over e times 1. So the derivative, the slope of the tangent line at e is 1 times 1 over e times 1. So it's just 1 over e. So we plug that in, 1 over e. And there's your answer. If you left the y minus 0, I mean, I wouldn't count off a point for leaving y minus 0, but typically if you have a plus or minus 0, you don't usually write that. Again, I don't know if on the AP test they leave that minus 0 there or not, but I can't tell you. I can't see those problems. Okay? So, knowing these